In this example, we're going to be simplifying rates. The first rate we've been given is 120 kilometers every 3 hours. So let's write 120 kilometers in 3 hours. And if we want to simplify that, we can see both of those numbers there have a common factor of 3. So let's divide both sides by 3. We get 40 kilometers on the left and we get 1 hour on the right, which means if we wanted, we could write that as 40 kilometers every 1 hour, or 40 kilometers per hour would be the more common way of writing that. 5,000 revolutions in 2.5 minutes. Let's write out that as a little sentence. So 5,000 revs in 2.5 minutes. And a simplified rate shouldn't have any fractions or decimals in it. So let's multiply both sides by 2 so that we have just whole numbers. It's 10,000 revs in 5 minutes. And now you can see there's a common factor there of 5. So let's divide both sides by 5. We get 2,000 revs or revolutions in 1 minute. And the most common way of writing that would be 2,000 revs per minute, or in fact some people would write 2,000 RPM. That stands for revolutions per minute.
In this example, we're going to determine distance, speed and time. A family took 3 hours to complete a journey of 210 kilometers from their home to their holiday house. The first thing we're going to do is find the average speed for the trip. We can use the DST, or distance, speed, time triangle, and cover the S to provide the formula for finding speed. That is, we find that speed, S, is equal to d over t, or distance divided by time. That is, average speed is equal to distance divided by time. In our question, we can see that the distance was 210 kilometers and the time was 3 hours. So we have 210 kilometers divided by 3 hours, which is 70 kilometers per hour. It's important that you remember to put the units in your answer. Now we're asked that if the family increases their average speed to 90 kilometers per hour, how many hours and minutes would the trip have taken? Again, we can use the DST triangle and cover the t to find the formula for time. Here we get that time is equal to distance over speed. So time is distance divided by speed. So the distance is 210 kilometers and the speed is now 90 kilometers per hour. So 210 divided by 90 is 2 1/3 hours. And converting to minutes, because we're asked for hours and minutes, 1/3 of an hour is 20 minutes. So the total time is 2 hours and 20 minutes.
In this example, we're going to be finding best buys. Let's decide which is better value out of 5 kilograms of potatoes for $3.80 and 3 kilograms of potatoes for $2.20. Now what we can do is we can work out how much 1 kilogram would cost in each of these options. Firstly, dividing option 1 by 5. This gives us 1 kilogram costing 76 cents. For option 2, we've been given that 3 kilograms cost $2.20, so let's divide both sides by 3. So 1 kilogram costs 73 cents. Therefore, the 3 kilogram bag is better value. An alternative method to this is we could work out how much $1 would buy you in both of these cases. So looking again at option 1, we've been told that $3.80 buys 5 kilograms. So let's divide both sides by 3.8. Option 2, $2.20 buys 3 kilograms. So dividing by 2.2. Option 2, for $1 we get more potatoes. Therefore, option 2, the 3 kilogram bag, is better value.
In this example, we're going to use direct proportion. The amount of fertilizer needed is directly proportional to the area of land being covered. A company claims that one 8 kilogram bag of its product will cover 10 meters squared. We want to know how many kilograms would be needed to cover 25 meters squared. So let's start by writing the rate. 8 kilograms per 10 meters squared. Well, dividing by 10 to simplify the rate to kilograms per meter squared, we get that 0.8 kilograms will cover each meter squared. So 0.8 kilograms per meter squared. We want to know how many kilograms would be needed to cover 25 meters squared. So we need to multiply it by 25. So 0.8 times 25 tells us that 20 kilograms are needed for 25 meters squared.